Good everyone. In this video I'll be talking about differentiation from first principle, how we can differentiate a given function from first principle. Just follow me, make sure you like the video and share it. Okay, let's look at it together. Differentiation from first principle. Differentiation from first principle from first principle. Okay. First principle. Okay. Let us consider one example. How can we differentiate a function using first principle? Let's have this example. Example. Differentiate y equals to x squared from first principle is simple as ABC. Amen. Okay. Let's write solution. Solution. Our y is equals to x squared. This is the function, and we want to differentiate this function from first principle. It's simple as ABC. You know, ordinarily, if we want to differentiate this function, our dy all over the x will give us 2x, two of us. This is the answer, two of us. Okay. Now, they said we should differentiate this function. We should not differentiate it direct, like this. Let us differentiate this function from first principle. That is what we want to look at. Amen? Okay, let us write out the formula for first principle. We know that our y plus dy is equals to f of x plus dx. Amen? This is the formula for first principle. So whenever you want to differentiate from first principle, this is what you are going to use all through. Okay. Then I'm going to show you how you use this formula. It's simple as ABC. Now, how can we use this formula for this function? Let me show you. Okay. Now, let us have a function of this one, y equals to f of x. Amen? Okay, this is a function, y equals to f of x. Look at this formula. If you can see what I am saying, you discover that this, most especially the right hand side, this and this, they are almost the same thing. Just that here we have only x here, two of us. But here we have x plus dx. Amen? Okay. So now, how can you use this formula to differentiate this? Let me use this one as an example to simplify so that you know what I'm talking about. Now, we have here f. We have here x. Okay. Let us have this function this way. Y equals to what? X squared. Okay, let's do it this way. X squared. What if we bracket this? It means here we have an invisible one, two of us. But this one is f, two of us, like this one, two of us. So, and this is x. It implies that this x here, we can use x plus dx to represent this x here. But mind you, this x has what? Square. X raised to the power of what? Square. So now, for us to write out this here, using this formula, what we will do, instead of x squared, we are going to, that is instead of f of x plus dx, we'll write it this way. our y plus dy is equals to, since I told you that this f is now invisible, but supposing here is 2x, would have write it this way, 2 all in brackets. Since this x means x plus the x plus what? The x. Note that it is squared, raised to power what? Square. But here, we don't have coefficient of x squared here. The coefficient of x squared here means invisible one, two of us. So this 2 is not necessary. Is that clear? You are not going to write f this way. Is that clear? Okay. So this is what you will write. So now, our y, we can what? Subtract y from both sides. If we subtract y from both sides, we're left with dy equals to x plus dx raised to the power of 2 minus what? Y. Amen? But note that your y is equals to what? X squared, two of us. So our dy is equals to x plus dx all in bracket square minus, if I were you, please don't forget to put bracket, x squared. It's very important. Why? Supposing we have, let's just say, exponential function, polynomial functions, or quadratic functions. That is what I mean. Assuming your y is equals to 2x squared plus 1. If you don't put the bracket, assuming you just, this is your y, and you just write 2x squared plus 1. You know that this minus will affect only 2x squared. And at the end of the day, we won't arrive at the answer. Why the minus supposed to affect 2x squared and this plus 1, two of us? It's because of that we are putting the bracket. So supposing is this, you are going to write the bracket this way, then you multiply, use the minus to multiply out. You have the right answer. Okay? Take note. So since we are talking about x squared, it's not necessary we write the bracket. So, but if it is polynomial functions or quadratic function, you make sure you put the bracket, then later, the next step, you try to multiply out the bracket. Okay, now, we want to expand this. Note that if we have a raised to the power 2, this is the same as a times a. So as we have x squared plus dx all squared, this is the same as x plus dx times x plus dx, two of us. But this one will take you time. Amen? This one will take you time. Why can't you go for Pascal triangle? Pascal triangle is 1, 1, 1, 1, 1 plus 1, 2, 2, 1. It means the coefficient is 1, 2, 1, 2, 1. Is that clear? This is what you will use in expanding this. You don't need to even stress yourself to this thing. The answer will just give you 1, 2, 1. As long as you have 1, 2, 1, it means this will be the answer. X squared plus 2x dx plus dx squared. So if you expand this, it will give you this idiom. You discover that it does not take me time to expand this by the help of what? Pascal triangle. Is that clear? But for the sake of malice, let us do it this way. Amen? So that I will carry along everybody. I know some of you, you may ask, how? Okay? Let us just expand it the way you used to do in your secondary school. Is that clear? So, this will give you, okay, let me just write out the answer. 1, 2, 1. This is x squared plus 2x dx plus dx squared. Okay, let's multiply. X times x, it will give us x squared. X times dx, it will give us plus x dx. Then x times x, sorry, dx times x, it will still give us x dx or dx x. Multiplication is commutative. Then plus dx times dx, it will give us dx squared. You see that I don't need a prophet to tell you. You see that what I was telling you, we can add this to give us x squared plus 2x dx plus the x squared. You see? Amen? So with the help of Pascal triangle, all these ones you are wasting your time. Amen? But for the sake of Malians, it's good. Okay. So now, it implies that this, instead of this square, this bracket, we are going to write out this. So our dy is equals to x plus, x squared, no, not x, x squared plus 2x dx, amen, plus the x squared minus x squared. Okay, look at this equation. You discover that this and this can cancel, true or false. So our dy is equals to 2x plus the x plus the x squared. Amen? Do you agree with me? Okay. So now at this point, we are going to divide through by dx. Amen? Let's write. Divide through by dx. Divide through by dx. This implies that our dy all over dx, this is equals to 2x. Oh, sorry, I made a mistake here. This is supposed to be 2x dx. Is that clear? Because if this one and this one cancel, we'll have 2x dx plus dx squared. Okay? So here will be 2x dx, yes, plus dx squared. Amen? Okay? So here will be 2x dx all over dx plus dx squared all over dx. Amen? Okay? Can I clean this part? Okay? Okay? Okay. So, if you agree with me, if you can see what I am saying, try to open your eye both in the spirit and physical, so that you will know this mathematics very well. Amen? Okay. So now, this and this will go. True or false? This and this will go. We are going to have dx, isn't it? Okay, I know Malians will ask, how? Okay, I'm going to show you here. Our dy all over dx is equals to 2x. Note that if we have dx squared, this is the same as dx dot times dx, true or false? So let's do it this way. Dx dot dx all over dx. Amen? So this and this will go. You discover that we'll be left with dx. So our dy all over dx is equals to 2x plus dx. Amen? You know, initially I told you that if we differentiate this function direct, we are going to have what? Our dy all over dx is going to give us 2x, isn't it? So if you can see what I am saying, you don't need a prophet to tell you. You discover that with this, we will obtain at the end of the day 2x. Okay, let us introduce limits. As limit dx tends to 0, it implies that anywhere you see dx in the equation, you substitute in what? 0. So our dy all over dx is equals to 2x plus what? 0. The dx is 0 as you take the limit. Okay, so therefore, our dy all over dx is equals to 2x. Is it difficult? Any question? Any question? No question? Thank you and God bless you.